This is an introduction to radicals. This will help you understand how to work with radicals. It will give you a basic overview. But before we go into radicals, let's look at back to basic algebra. If you had 2x plus 3x, you knew that you could add them. And basically, when you looked at it, you had 2 and 3 were your coefficients in front of the x's, which means that you had 2x's plus 3 more x's. So when we go back to our radicals, well, to finish this one, 2x plus 3x would be 5x. Now look at what happened if I had 2 rad 2 plus 3 rad 2. Well, you treat it the exact same way. So it would be 2 square root 2 plus 3 square root 2, and I use radicals and square roots interchangeably here. So that would give you 5 root 2, and that is it in its simplest form. So what happens when you have 2x plus 3x plus 5y? How would you simplify that? Well, the only ones you could combine would be your x's. So it would be, let me write that little meter, 5x plus 5y, and that is it in its simplest form because you cannot combine your x's and your y's. See how this translates to radicals. If I had 2 root 2 plus 3 root 2 plus 5 root 3. Once again, I can only combine those that have the same radicals. So that would give me 5 root 2 plus 5 root 3. And that is it in its simplest form. So now that we know how to add, let's go on to multiplying radicals. Once again, let's start with basic algebra. If I had x times y, that would give me xy, wouldn't it? So now, let's throw radicals into this equation. Root 2 times root 3 would give me root 2 times 3, which is equal to root 6. And that is it in its simplest form. Okay? Let's talk about something else. So if I had, continue with this, what if I had 2x times y? That would give me 2xy, wouldn't it? So, let's try it with radicals. Let's try 2 root 2 times root 3. That would give me 2 root 2 times 3, which would be 2 root 6. We're following the exact same procedures we did for algebra, but with radicals. Well, radicals are going to be a little different, and let me take you a little further on multiplying these now. Let's have the example of 2 root 6 times 3 root 3. So when we do it, we know we're going to first take our coefficients. 2 times 3 is 6, and then it becomes root 6 times 3, which gives us 6 root 18. It's so important that you have to know your prime numbers, because in simplest terms, you want to take anything you can out of the radical and move it in front. So what you have to do is make a factor tree of 18. This is where your prime numbers come in. Well, we know that's 2 times 9, which is 3 times 3, correct? So what this gives us, if I was to break this down, remember that, running out of space here, is that, I'm going to bring this all the way over here. So 6 root 18, if I want to break that out back into multiplication, would be 6 root 2 times 3 times 3. Because if I multiply 2 times 3 times 3, that would take us back to 18. So let me rewrite it again, but with square roots. So I've got 6 times root 2 times 3 squared. Square roots and square cancel each other out. Or if you want to look at it another way, that would be 2 times 9, and we know the square root of 9 is 3. So look at either the square root and the 2 cancel each other out, and you move that 3 in front. So the 6 comes down, this 3 moves outside, it's being multiplied by it, and this is your remainder. There's nothing you can do with that. So it stays just like that. So 6 times 3 is, so your answer in simplified terms is 18 root 2. Let's practice a couple more of those. I know those are a little bit confusing. So if I had 3 root 8, let's just start with 3 root 8 and simplify that. 8's not a prime number, so let's do a factor tree to see where 8 takes us. That's 2 times 4, which is 2 times 2. So actually, root 8 is 2 times 2 times 2. But I'm working with a square root, so I'm going to want to bunch them in groups of squares. So 3 root 8 is the same as 3 times root 2 times 2 squared, correct? That would be 2 in the first power. Once again, I know that I'm going to bring my 3 down. I know the square root and the square cancel each other out. If you want to look at it another way, it would be 2 to the 4. 4, the square root of 4 is 2. Bring that out. What's left is our remainder right here. Bring that down. That square root 2 we did not have to put to the first power. And that will give us 6 root 2. Now, let's look at division. If I had 6x over x, you would realize that those x's would cancel out, and you would just be left with 6. Same procedures for root 2, or square root. So if I had 6 root 3 over root 3, the root 3's would cancel each other out, and you would be left with 6. Now, the one thing I do have to explain is that you cannot have a radical left in the denominator. And they use this term rationalizing the denominator. So if my answer was 6 root 3, well, since we can't have a radical in the denominator, the easiest way to get rid of it is to multiply it by itself. Let's see what happens when we do that. So if we have root 3 over root 3, we can do this because root 3 over root 3 is the same as 1, so I'm doing an equivalent fraction. So what I have is 6 root 3 over root 3 times 3, correct? Now we can look at this 2 different ways, whichever way is easier for you. It can be 6 root 3 over the square root of 9, and so that we leave our numerator alone, the square root of 9 is 3. Or we can look at it this way, 6 root 3 is the same as root 3 squared. Remember the square and the square root, think of it as canceling each other out. That will leave you 6 root 3 over 3. Either way you do this, you will get the same answer. Now I'm going to take you to a little easier way of doing it. So if I had 5 over square root 2. So, without going through all those steps, if it's something as simple as this, if you worked it all out and multiplied it by root 2 over root 2, what you're going to find is that it becomes your original numerator times your original denominator over the square of your denominator. So that's another way of doing it. This is a brief overview. I will be having more videos on this. Stay tuned.